Hi everyone, my name is Louis de Gouveia. I've been in the data business for over 10 years. And during those 10 years, I've seen more and more data solutions that are out there, more ways to tackle data. And there's many different ways, but I've seen a new trend coming in now in South Africa, and it's around data virtualization. And I'm going to focus today on elaborating or giving you guys insights into how data virtualization is the next big thing.
Oh, thanks, Louis. My name is Basha Ramasa. Been in IT for about 20 odd years now, and a lot of my focus has been around data and in all sorts of different types of roles, whether it was ETL, data integration, business intelligence, data governance. There's always been this thing about looking for the next best type of technology or way to work with our data and actually harness the value out of it. So I'm very keen to share a bit more around data virtualization with my colleague Louis today. And maybe Louis, starting with that point, we hear this term data virtualization, we hear the term DV, but what is it really? And could you explain it to us in a way that would make sense to anyone?
Yeah, no, we can do that. So I think the easiest way for us to explain this is to move to a whiteboard, and then we can really, draw it out, keep it simple, and explain it. So let's move over to a whiteboard.
Okay.
All right. Okay, so I'm going to use a baking scenario. I think everyone can relate to an actual baking scenario. A simple scenario where we bake a cake. So when we bake a cake, what do we need? If we look at that, we need flour.
Mm-hmm.
We need milk. We need eggs. And then we need something for flavor, whether it'll be chocolate, if we make chocolate cake, carrot, or maybe even a vanilla cake. All right. Then, if we take all of this, it'll go through a process where we're obviously going to mix it and put it in an oven.
Mm-hmm.
And then after that, hopefully we have a cake. And then hopefully we have someone who's willing to eat it.
It'll be a good cake, yeah.
Yeah, so hopefully that is our scenario. But now you might say, well, how does this actually relate to data virtualization? Yeah, we all know how to bake, but how does this relate? Well, it's pretty simple. If we look at this, in the beginning part, our ingredients, we can see that as our data. Okay, so this here can be our data. Then we can see the oven as our DV engine. But this is kind of like a new type of oven. It's an instant kind of oven. We don't have to wait the whole 60 minutes like you'd usually for baking cake. I'm assuming it's 60, 80 minutes you'd wait for a cake. And then we can say that our cake is our analytics output.
Okay.
All right. And then the person that's eating the cake is our end user. All right. Now, the difference here with this is, if we look at most data solutions out there, they really kind of take the flour, the milk, the chocolate, and everything and put it into the oven or into a specific data layer, and then you can get your analytics out of it. But the problem with this is, if we had to mix all these flavors like chocolate, carrot, and vanilla, we're not really going to give the end user what he's looking for, and we're probably going to end up with an unhappy user at the end. That's really what we're going to end up with. Whereas now DB kind of gives us the opposite, where the end user can actually kind of ask for a chocolate cake, and that will be constructed. So let me just change this color here just to give you an idea. So if an end user wants to get a chocolate cake, he's going to need it to have the ingredients, obviously chocolate, egg, milk, flour. Now, when he makes that request, he will make that request. The DV engine, which is our oven, will automatically know how to go and select the flour, milk, eggs, and chocolate because he's requesting a chocolate cake. But at the same time, if our end user, the next day needs a different view of his analytics, we'll see it differently. If he requests a carrot cake, then, when he makes that request, it will know automatically to get the carrot cake, you'll need different ingredients. So whether it be flour, milk, and carrot, it will then give it. So that is kind of ultimately the difference between data virtualization, is that when the end user requests it, it kind of then sees, okay, you're asking for this type of cake today, and then this type of cake requires these ingredients, and it will only go fetch those ingredients. It won't go fetch all of the ingredients, because then you're going to have too much, and you're going to have basically an outlook or the visualization that you're not looking for, or data set you're not looking for. But data visualization can even make it a little bit better. This is where it gets better, is that in the sense that whatever you select, if the user can also actually say, I don't want a full cake today. I actually only just want a quarter of the cake, and we can then deliver a quarter of that cake. And that's where data virtualization also comes in. So automatically, the user can come in, ask for a cake, but say half the cake, and make it, shall we say, carrot flavor. And obviously now if it's half the cake, it knows that, to get a carrot cake, it needs to use half the quantity of carrot, half the quantity of flour, milk to get that view. And I think the other important thing here is it'll be instant. We don't have to wait. The DV engine is quite fast, instant, and it's not like the traditional oven where we wait for 90 minutes.
Okay, sounds like more Louis, so data bit, but if we make this more real in terms of what our data landscape looks like, or our ecosystem looks like for our clients, there's usually multiple types of data sources and data engines. There's a data lake, there's a data warehouse, there's probably a cloud in there somewhere. How does that relate to this?
All right, so that's fine. So let's erase everything we've got here. So let me just erase what we got here, and then we can start with that. So how does this look in the real world, like you've mentioned? So the data virtualization engine will be this layer that will sit here. All right. Okay, so we have our DV engine. Okay, then we'll have the databases. We'll have our data lake, like you mentioned. And then we'll have our cloud. Okay, so we've got our DB, we've got our data lake, and we've got our cloud. All right. So the way that this will work in the real world is, whoops, got the wrong thing there. This data virtualization will be told, where to find the data and what sets of data. So you'll tell it, here we go, here's your sets of data. And then a model will be construed or made. And this model will be the equivalent to, how should we say, our cake. And then the end user can now come and request from this model, I would like a carrot cake. And if it wants a carrot cake, and that cake then requires data from two of these tables. So let's draw in another color. Once, to get that carrot cake, if it only needs data from here, and here, and here, it will only go and get from here, from these sources as an example. So that's that, again, it comes to that whole approach that if they're asking for a carrot cake, we only go get what we need exactly from the source, and we don't even then touch the other cloud source. And obviously, when in real life, it's not going to be a carrot cake. This model that we're talking about here could be like a home loans model or a sales model, something specific to that business. But the point here is they will only be exposed to the model. They won't be exposed to all the ingredients or all the data sets in the background, because that's kind of also a challenge that we see with a lot of our customers is we tend to make these beautiful data warehouses or data lakes, and then they've got a whole bunch of tables to choose from, especially when we talk about self-service. Whereas now from a data visualization perspective, we're just giving them one model, and that's what they need to consume. They don't need to worry about linking or doing anything else. Sure.
Louis, this looks cool. And it's interesting when you know what the sources are, and then you've got these pipelines built into it, into this DV engine, and you've got a customer who knows he wants, the carrot cake, chocolate cake, or something like that. But in reality, when we work with our clients, it's seldom that layer stays static. And that layer I'm describing is the database, data lake, or cloud environment. So, for example, if we had a client who came to us with a hybrid cloud strategy, meaning they've got all these other pieces that you've got on your picture, but they want to add another cloud piece into it, how would that fit into the DV storyline?
So this is where it's pretty interesting, because in data virtualization, we're not loading data, we're not pulling data. We can easily add and adapt quite easy without actually interrupting the business. So that other cloud that you mentioned, so it doesn't matter how many clouds it is. So let's say you got your cloud number 2 here. We can easily make that connection and bring in the data, and then we can make it part of the model. Or you could have even just replaced the switch over completely. So there's two ways to approach it. We can then easily make it, add the extra columns. The original data set won't be disturbed because in reality, the original data set was always made at runtime when it goes and fetches the data. And you can just append to it. So it'll be just adding extra columns to it. Or if we were going to switch completely, you would just, after you've based the table there, you would just switch the connection. And it would be fairly straightforward. So it's quite agile in that perspective.
Okay, I'm loving the agility, but again, and probably this is the years past of working with big data sets talking here, but when we're in deepest, darkest Africa, we know there's bandwidth issues, and we know the costs of storage and all the other challenges. So I need to understand a bit more about exactly how does this work that you're not copying data or moving data. How is this engine actually working?
All right, it's not a problem. I just want to make a little extra room here to make notes. So we've discussed Agile, all right? So now you want to know, how do we handle the bandwidth and that type of concept. So what we need to remember is because we are working real time, as I mentioned, so that's another valid point here is we've got to say, this is real time. So that is great, another point. And because it's real time, what it does is it goes and gets the data. But now you're saying, bandwidth could be a problem, going and fetch the data each time. So what we can do is DB has quite a unique engine in the sense that it can identify all the common sets of data, and also we can set up caching. So we can cache the data over here, and then it doesn't always need to go and fetch new sets of data. So we can cache, and the most frequent used data will be cached, and we'll go and get the data from there. So it won't always go to the data lake and fetch large sets of data. It will cache exactly what it requires. And, in our scenario with a cake, it will know that it needs all the types of subsets of data to make the different variations of the cake. And it will cache that amount of data over there, and then we can use that. Obviously, if we go back and we ask for a little bit more than a cake, so maybe some extra topics that we never accounted for, then it will go and make a call. But the call will be reduced, and it'll be a lot less. And again, we're only fetching really what we want. So that, again, saves us on bandwidth.
Okay, so we've got the ability, we've got the real-time access to data, and we're talking about bandwidth. But the other challenge we find with technologies is always skills. So what does it mean from a skill perspective? Does this mean a whole new horde of people that need to be hired to understand DV, or what does the future of these types of roles look like?
So this is what's the great thing about this. Even though it's a completely new concept and we've got this new DV engine, at the end of the day, the DV engine is making use of the skills that you already have in your organization. It makes use of SQL, so there's nothing new. So we're using SQL in here, and it's using what we refer to as traditional modeling. Modeling in the sense that you would go into the DV engine and say, these tables make up this model. So this model here that we spoke about, that is our cake that I'm just coloring in a little bit more for us to see. Here, this model. All you're doing there is you're literally saying those tables that we see a little bit below, how they link, how they join, and doing a little bit of grouping and whereby it's all in a graphic we're using a base. So it's pretty simple, pretty straightforward. And then from there in the back end, it generates its own type of SQL, and that SQL is very similar to the normal structured query language. So if you've got already skills in-house that's already doing some data projects, there's no need to reskill. And it's a quick win or quick thing to learn, the DV engine itself. But other than that, your skills should be covered, and you should be able to repurpose pretty easily any skills you have.
Well, that's quite promising. I see basic coding language for most people working with data. So now that's a positive there. And then I guess, Louis, we've spoken about the theory of it, and we've spoken a bit about, I guess, the architecture of it. In reading up about these things, I see a lot of case studies overseas. When we think back to South Africa, what are the type of case studies that have been implemented here?
So let me rub this out and give you some case studies that have been implemented here. So there are customers in South Africa already using this technology. So it's not completely brand new, but it's not as mainstream as other things. And I do foresee it becoming quite a big mainstream. So I'm going to speak about two customers, or two that we've implemented in South Africa. One in the manufacturing industry. So the one in the manufacturing industry really uses DV, as I've explained from the cake scenario. The only difference here is they're using, the one source is SAP, and I'm highlighting this because SAP if you don't know SAP, it's not really the easiest system to get data out of, because SAP is usually written or it's done in an app stack. So that is its native language. And getting data out of SAP is not always easy, especially real time. And most customers would end up dumping files and all of that type of stuff. Here, we don't have to dump files. All that has to happen is we make a straight connection and we can automatically start harvesting and making that data available. So the same as in our cake scenario, we'll take all those tables that we've mentioned from the different sources, and we'll make a model, whether it be for SAP SD module or whether it be the HR module or finance module, doesn't matter. We can bring all that data together, and once again, it's real time. So that's the other thing, when we're talking about real time, is in a traditional SAP environment, they would usually over here have what they refer to as a BW system, and BW traditionally only gets updated once a day. So again, it's a great value in the sense that we're combining SAP and non-SAP data, and we don't have to wait for 90 uploads like we do with BW, and it's instant, and we still have that same agility where we can add extra tables. And again, because we're not moving it, we don't have to wait for these data loads. And even if you are happy to wait for the data loads, requesting new things to be added into SAP BW can be quite a laborious task, because there's multiple layers that they have to change and then reload the data in many cases when they add extra columns. Then the second scenario is in the banking industry. So we've had a client that had terabytes of data in a red, shall we say, badge solution, popular database. And then they needed to reduce license costs, with COVID and everything, you need to reduce license costs. So they opted to go to, how should we say, more kind of like a Hadoop kind of technology to make kind of like a data lake. And what they then did is they couldn't interrupt people. They couldn't interrupt their end users. So again, DB was used. All the reports came out over here. So all of the reports are available via DB. And then what they started doing is they started migrating the data. They migrated the data. And as they migrated the data, they just automatically just changed the connection to DB. The models that was over here remained the same. The only difference is they switched the connection, and then the reports carried on using the same models. And that really was for them a huge saving, in the sense that, one, they didn't have to redesign all the reports. Two, they could move terabytes of data, in the back end to their Hadoop platform. You're not worried about disrupting use, because at the end of the day, to move this amount of data is not going to be an overnight exercise. And it also gave them the ability to make any changes they want, and then, just get the DB or the data virtualization layer to point to this new source. But yeah, it was quite creative, neat way to approach it.
Yeah. So if I hear you, core cases have been around, I guess, making sense of data that's quite difficult to access or make meaning out of. And from a second perspective, not disrupting your end user base while trying to do changes to core systems beneath that. Okay. Are there any use cases you think DB is not a strong contestant for?
Look, at this stage, DB can do most use cases. If for whatever reason, you need to save maybe a specific state and you're not able to redo that specific state in memory, then that could be a scenario where it's not the best used for. But one scenario that it is pretty good for, that I think we should mention, because cloud is the new thing going forward. Everyone's talking about cloud. And I think the biggest thing that what is happening with cloud is, at the end of the day, we've got someone, our customers, they've got on-premise solutions. Solutions. And then what they then do is they usually choose a cloud. So, and let's say it can be whatever, it can be AWS. But as time evolves, we've seen our customers, they go for a multi-cloud strategy. So what happens is they then go and they get Azure, or they get whatever else. The other popular one is Google Cloud, all referred to as GCP. Okay, Google Cloud. But now the problem is, when you start having some data there, some data there, and some data there, it can become kind of a problem in the sense that you don't have one view. And then let's not forget, you have some data there. And if you're quite a large organization, some, will migrate to AWS in that organization, a business unit, and then another business unit will migrate to Azure. And this kind of creates then a problem. And Okay, so this is where data virtualization comes in handy, because what we can do is we can, put in the data virtualization solution, and the data virtualization solution can then be used to virtualize data from all three and provide one thin layer for all the end users to use. And that layer can be either here, I'm just showing it on the on-premise side, but that thin layer can also be on the cloud or wherever. But the point is, it can connect all of those three data sets. And because it uses caching technology, it can go cache the data from the three different clouds, bring it to on-premise, or you could be hosting it on one of the clouds and bring it from the two other clouds plus on-premise. But the point is, we've got that thin layer, and then from that thin layer, we can provide that data model that the user, is keen to get hold of. And it kind of brings the glue together. And again, we don't have to move any of this data between the clouds or on-prem or anything like that. And again, if we choose to one day, stop using one of the clouds, again, we just then, remove that connection and everything can work and proceed from that perspective.
Okay. Well, Louis, that sounds very exciting, especially knowing how many people are on that cloud journey right now. So I guess the next question is just, given all of this, where do you start with it? And maybe I could stop sharing the whiteboard.
Yeah, so look, the easiest way to, see how to move forward with this is, book a free data virtualization assessment with us here at iOCO. All you got to do is, here's our, details, pop us an email, and then, we'll gladly come out, walk through with you and kind of get an understanding of your environment and say, with your environment, this is the benefits that we can see with data virtualization. And you'll see that I've got a little picture here on the slide. That is actually, we are able to do a data virtualization return on investment for you. And we can tell you from that return on investment, should you, implement data virtualization, what is the savings you'll see? Because as I've mentioned through, explaining, we can, because we're not moving data and because everything's real time, we actually have a large reduction in how we do the work, but also a normal typical data warehouse project, we can save up to 60, 80% of that time. And again, that's cost savings to you. But what is more important, you can come out and actually show this as an actual calculation. And yeah, I think that's the best and easiest way is to reach out to us. We'll come through, do an assessment, and there's no cost. I always say to our customers, there's no cost to talk.
Cool. Thanks, Louis, and thanks everyone for tuning in today. And yeah, hope to see you back later in the day.
Thanks, Sarah.